Hey there everyone, and welcome to the first video of my Math 140, also known as Calculus 1 playlist. The topic of today's video is going to be limits and continuity. So we're going to go over just basically the definition of what a limit is using this concept of a tangent and a secant line. So now before we begin, let's just define or give a brief textual definition of what a tangent versus a secant line is. So a tangent line is a line that touches a curve at exactly one point, while a secant line is a line that connects any 2 points on a curve. So roughly, just, verbally, that's what you would define a tangent line and a secant line as. So if you look at the bottom, you can see graphically the difference between the two. Like I said, the one on the left is your tangent line. It touches the point, let's call this graph f of x equals x squared. So it touches f of x equals x squared at exactly a single point, which is point P right here. And on the right side, you can see a secant line, and you can see how it touches the graph of f of x equals x squared at 2 points, which is Q and P. Alright. So, despite from their differences graphically, they also have differences mathematically, of how you solve them and how you go about, finding them. But either way, one similarity is that, at the end of the day, they're both lines. So at the end of the day, they're both they can both be described or defined by the linear equation, basically, which is y equals mx plus b. And so, m basically being your slope, and then the slope of any line is just, y1 minus y2 over x1 minus x2. Or another way to look at that is using a and b like I use here, you can say f of b minus f of a over b minus a. And so this description right here represents your secant line. Right, because you're giving two different points. And that's because you see I'm giving points A and f of A and B and f of B. So two different points. That's one way you can tell whether or not you're dealing with a secant versus a tangent line. Because with a secant line, you're usually given 2 points on the graph that it touches, but a tangent line usually comes with 1 point. Okay, so let's try and find an equation for, or rather the slope of a secant line and a tangent line. Giving the function f of x is equal to x squared, like we talked about in the previous slide. Alright, first we're going to do the secant line. Let's do this. So we're going to find their slopes. Actually, let's do this one. Okay. So A. Okay. So how do you find the slope of a secant line? It's simple. They've given us, we have the points 1 and 1 and 0, 0. So these are going to be our x1, y1, x2, y2, right? So we're just going to say, okay, this is equal to, the slope is equal to y2, which is 0, minus y1, which is 1, over also 0 minus 1. Do that, you get negative 1 over negative 1, which is equal to 1. Awesome. So the slope of our secant line here is equal to 1. And if you wanted to write that as an equation, the equation for a secant line, you would have to use the point slope formula. The point slope formula goes something like, let me get my pen back, y minus y1 is equal to m, which is your slope, times x minus x1. So it doesn't matter what set of points you pick, you just pick any set of points. I'm going to pick 0, 0. So that's, let me get my pen back one more time. That's y minus 0 is equal to our slope of 1 times x is 0. I'm sorry, x is just x. Let me get an eraser here. Get rid of that. Alright, gone. Get my pen back. Okay. X minus 0. Distribute that, you have y is equal to slope of 1, x, and there no x-intercept, or I'm just going to write plus 0, just so it can look like the equation of the line that we're all so used to. Alright, let's move on to problem B, finding the slope of the tangent line at the point 2, 4. As I mentioned earlier, when you're dealing with tangent lines, you're usually only going to be given 1 point, and this is how you solve that. So let's do that here. Get my pen. Okay, B. So we're trying to find the tangent line at the point 2, 4. Let me write that. So the formula for that, we're going to have to introduce a concept called the limit. And I'm probably going to make a video just describing why limits are important, or like, the importance of a limit later on. But for now, we're going to focus on defining the limit as a tangent line. So the limit as x approaches 2, right? You just pick your x value there of, or let's look at the arbitrary formula first before I go into the exact formula. So let's get rid of this. So we're going to say the limit as x approaches a, right, of f of b minus f of a divided by b minus a, right? So this right here is basically your definition of the limit. Actually, no, I made a mistake, I'm sorry. We're gonna replace the b with x. Yeah, I just realized that doesn't make sense. So, yeah. Apologies for the misconception. So this is an x, that's an x. Now it makes perfect sense. Okay, this statement makes sense. The one that was on the screen earlier made no sense at all. Anyways, so this is basically your generic equation for a limit. So now let's make it more specific to our case, where we have the points 2 and 4, and our function f of x. Let me get my pen back. And our function f of x, right, is equal to x squared. So it's going to be the limit as x approaches 2, right, of f of x minus f of 2 over x minus 2. Alright, get some more room here. So this is what our limit equals to. So what was f of x again? F of x, let's rewrite the limit expression. So the limit as x approaches 2, f of x equals x squared, right? Minus, what's 2 squared? It's 4 over x minus 2. So now if you look at this expression, if you've taken any basic algebra, you can tell that the numerator right here, get my pen back one more time, the numerator right here is basically the difference of two perfect squares. So we can rewrite it as something like the limit as x approaches 2 of x minus 2 times x plus 2 over x minus 2. And you can see that this cancels out with the denominator. And so what we're left with is the limit as x approaches 2 of x plus 2. The next step you take is you just plug this number 2 right into x, and whatever you get is the slope of your tangent line. So we plug it into x, so we say 2 plus 2 equals 4. So our slope, m, of this tangent line is equal to 4. And the same way, if you wanted me to write it in the linear equation form, we take the point slope form that we're so used to, which is, again, I'll write it again once I get my pen back. Y minus y1 is equal to m times x minus x1. And our x and y coordinates were 2 and 4, if I remember correctly. So that would be y minus 4 is equal to, slope is 4, of x minus 2. Distribute that, we have y minus 4 is equal to 4x minus 8. Add 4 to both sides. We have y is equal to 4x minus 4. And that is the equation of our tangent line right there. Alright, so let's move on to the next example. So this example is a bit more complicated, only in the sense that the function is more difficult, but still conceptually is the exact same thing. So we're giving the function f of x is equal to sine of x at the point 0, 0. We're asked to find the tangent line of f of x equals sine x at the point 0, 0. So how do we do that? The same exact way. We say, okay, we're going to take, first of all, we find the we find the limit, find the slope, and then once you find the slope, you use the point-slope formula, and then you find the equation of the line. Alright, so let's get my pen back real quick. So the limit, so slope m is equal to the limit as x approaches 0, right, of sine, sine of x, get my pen back, sine of x minus sine of 0 over x minus 0. Alright, so if we know our unit circle, let's just go ahead and draw that right here. This is 0, this is pi over 2, this is negative pi, and this is, this is just pi. Let's not call it negative pi. Nah. Apologies again. This is just pi, one whole pi, not negative. And this is 3 pi over 2. That's a 3. Okay, 3 pi over 2. So what's the value of the y-coordinate when our angle is at 0? There is no y-coordinate, right? So sine of 0 is just going to equal 0. So we're going to be left with an expression that looks like the limit as x approaches 0 of sine of x over x. Now, if you look at this problem, there really is no way, at least in Calculus 1, that you can solve this mathematically or even algebraically, in whatever way. The only way you can do that is if you were in Calc 2 and you use this thing called L'Hopital's rule. But since this is a Calc 1 tutorial, just don't even worry about that. But take my word for this, that the answer of the limit as x approaches 0 of sine x over x is equal to 1. I remember when I took this class, there was a list of limits that we had to memorize, memorize their answers, that is, simply because, there wasn't any way to solve them mathematically or algebraically in Calculus 1. So we just had to memorize these limits, and this is one of them that I urge you to memorize. It'll come really handy when you're taking a quiz or an exam or anything like that, just to know that the limit is x approaches 0 sine x over x equals 1. But in my next video, at the start of it, I'll probably compile a list of all these limit identities, as they're called, for you to memorize. I think there should be nothing less than maybe 5 of them in total. So you could just memorize them, and then whenever you see them, you know them. So thank you for watching this video and supporting this channel. Like always, if you have any question that you wish me to answer, or any problems, a set of problems that you have that you want me to make a future video on, feel free to email me. My email is in the link. A link to my email is going to be in the description. So yeah, you could just email me and I'll most certainly make a video of it in the future. Thanks for being here, and see you.